Okay, so for number 9, we have a radical equation, and in this case we need all the denominators to be the same. In order to make these denominators be the same, well, the goal is to have the denominators be the same, and when the denominators are the same, then we can just focus on the numerators to solve for x. All right, so our job here, our task here is to solve for x. So let's start by working on making the denominators the same. Now we simply can't add 4 to this denominator and then all of the denominators will be x plus 4. We can't do that. All right, we can't just say plus 4 right here, because if we do that in the denominator, then we also have to do that in the numerator, and that will not give us the same fraction if we do that. For example, if I have 1 over 5, okay, if we were to multiply 2 on top and bottom, it will give us 2 over 10. And when you reduce that, it does give us 1 over 5, that same fraction that I began with. But if I have 1 over 5 and then I add 2 to the bottom and the top, that'll give me 3 over 7. And there's no way to reduce that back down to 1 over 5. Okay, so let's just erase this. It's just an explanation to explain why we can't just simply add 4 to the numerator and the denominator. So let's go back and let's do the problem the correct way. All right, let's start by rewriting the equation. We get 1 over x. I'm going to leave a little space because we're going to need it. Minus 1 over x plus 4. I'm going to keep these in parentheses, just keep them together. Equals x minus 3, keep those together, over x plus 4. And we're going to keep those together as well. Okay, so we need all the denominators to be the same. So the one here on the left, if we just simply multiply x plus 4, now it's going to look similar to the one over here. But if we multiply x plus 4 in the denominator, then we also need to multiply x plus 4 in the numerator, and it will give us the same fraction. So we haven't changed much about that fraction. It just looks a little different. All right, so here we're going to multiply x in the denominator and the numerator. And here we're going to multiply x in the denominator and also in the numerator. And as you can see, in the denominator we have x times x plus 4, x times x plus 4, and x times x plus 4. So now the denominators are all the same. Now that the denominators are the same, you can just take the numerators and just focus only on the numerators. So we're going to say 1 times x plus 4, which is x plus 4. Okay, x times 1 is x. Okay, equal. Okay, let's just go ahead and distribute here. X times x is x squared. X times 3 is negative 3x. Okay, as you can see here, we have an x and a negative x. All right, when you combine them together, you get 0. You have this 4. This 4, you can move it over, becomes negative 4. So I have 0 equals x squared minus 3x minus 4, which gives us a trinomial, polynomial that that can be factored. So we factor it by setting our two sets of parentheses, again equal to 0. We know that x times x gives me x squared. We know that 4 times 1 gives me 4, but we need it to be negative 4. So let's let the 4 be negative and the 1 be positive. Okay, now if we do our outer term, which is 1x, and our inner term, which is negative 4x together, that will give us negative 3x in the middle. So this is the correct factorization. All right, and now we're going to use the zero product property. States that if you multiply two things and they both equal to, and it equals to 0, the product equals 0. Therefore, we can assume that both of these terms, or either one of these terms, are 0. So x plus 1 is 0, or x equals 0. So we solve by adding 4 to both sides. We end up with x is equal to 4, and x is equal to negative 1. Okay, so these are both potential solutions. But which one is the correct solution? Well, we have a reminder here. It says, don't forget to check the domain restrictions. So if we look back to the initial problem, what can we say? Well, we know that the denominator of any fraction cannot be equal to 0. So if we try this solution, x equals 4, is it possible for us to get a 0 as the denominator? Okay, and it is not possible for us to get a 0 as the denominator, so this is a possible solution. This is a solution. And then if we take x and distribute and include negative 1 in for x, we'll notice that we will also not get 0. So this is also another solution. So we have two solutions to this equation. X equals 4 and x equals negative 1.